Okay, so let's talk about a few of these. As usual, I've got like neat solutions written up. They're not in Blackboard yet, but they will be shortly. So don't feel like you need to like scramble to copy things down and stuff. Just get it later. Just try to be, present. So given a rational function, so here it is. Find all the following stuff. Again, we talked a little bit about like where all that stuff comes from. Setting the denominator equal to 0 tells you about domain and discontinuities, and those are vertical asymptotes or holes. So like where, bad stuff happens because you can't divide by 0. Looking at the leading terms and thinking about, okay, what happens when x is a bajillion d, what happens eventually. Tells us how to find horizontal asymptotes. Intercepts, nothing new. For y-intercept, let x be 0. For an x-intercept, let y be 0. Sorry, I don't remember where I'm trying to go here. So doing all of that stuff with this thing, you can sort of pick all this stuff out, right? So it's got vertical asymptotes at -7 and 2, I think, right? I mean, walking around, it looked like everybody pretty much, got to where you needed to be on this. So horizontal asymptote, be a little bit careful there because what are the leading terms here on the top and bottom? On the top, it's 3x squared. In the denominator, it's -3x squared. So just be a little bit careful. Like I am trying to be a little bit sneaky there, switching the order on the thing at the bottom, but that's because like this is a safe space, right? This is making sure we know what things mean. Leading doesn't necessarily mean first unless it's in like descending order, right? So the first part of this would be 6x, but the bigger part would be -3x squared. So what does that tell you about horizontal asymptote stuff? And y equals -1. Yeah, because looking at those leading terms, canceling, reducing, you get -3/3, then that reduces to -1. So there's a horizontal asymptote of y equals -1. Okay. Here, because I think this is probably more likely to, have given you a little bit of trouble maybe. We're working the other way, right? So I would, for this kind of thing, I would just encourage you to think about, basically undoing all the stuff you did on number 1, working backwards. If there's a vertical asymptote at x equals 4, what does that tell you? Say again? What happens at x equals -4? It's got to be a place where denominator ends up being 0, right? Denominator, it's a tough word. X equals 4 is the 0 of the denominator. Well, if it's a 0 of the denominator, then x minus 4 is a factor of the denominator, right? Notice like I asked you for this thing to write an equation in factored form. Well, okay, so what I've just told you with that first piece of information is that part of the denominator anyway has a factor that looks like x minus 4. That makes 4 a 0 of the denominator. That makes the thing undefined. And if that's not sort of balanced out by what's going on the top, that's going to be a vertical asymptote. Having a hole in the graph at x equals -1, well, a hole in the graph on one hand tells you the same thing. That's a place where it's not continuous. So it's a place where it's not defined. So it's a place where there's a 0 in the denominator and you get a factor from that. Being a hole rather than a vertical asymptote means that gets kind of balanced out by what's going on in the top, right? That's the way holes happen. You have something that would be like 0/0. So -1, you get 0 in the top and 0 in the bottom. That's going to cause a hole or removable discontinuity to happen. Okay, so I get those. Then think through this other stuff. Horizontal asymptote at y equals 0. What has to happen for that to happen? Or think about what you have so far. What are the leading terms here? X over x squared. X over x squared would reduce to 1 over x. What does 1 over x do if x is a bajillion d? It's really small. So this goes to 0. That means you get a horizontal asymptote like 0. Oh, okay. So that part just sort of took care of itself, right? I don't need to do anything else to adjust that. No x-intercepts. X-intercepts would come from where the top is 0. That just happens at -1 here. But we already know -1 is actually a hole in the graph. So it's not an intercept then. It's not a point that it goes through because it's not defined there. Okay, so that part took care of itself too. Y-intercept at 0, comma -1/4. Plug 0 into this, what do you get? -1/4. Okay, so that part took care of itself too. Like that kind of did you solid there, right? If you can think through the first two parts and what that means about the factors, right? Factor that looks like x minus 4. Factor that looks like x plus 1, but in top and bottom because it's a hole rather than a vertical asymptote. And then just check the other stuff, right? First, check to see if it works. If it doesn't, then maybe do something. Like if I wanted this to have a horizontal asymptote of 1, well, I need another factor of x in the top, right? Okay, I don't have watch on still. It's been months now. The equation problems, hopefully, look back at notes, like they should be fairly straightforward, not a huge deal. The negative exponent thing, just remember that those mean reciprocals. So x to the -2 is the same thing as the reciprocal of x squared, so 1 over x squared. X to the -1 is 1 over x. That's 3 times 1 over x. Or 3 over x. The 3 doesn't move down because it's not, like the whole thing to the -1, right? And then you can do kind of the usual thing, find the LCD, multiply through, solve, good to go. This one I wanted to spend a little bit of time with because we haven't had a lot of time to talk about applications in this chapter so far. Here's a function. It's rational, right? There's a quadratic on top, quadratic on bottom. And we're told that this function models the pH level of a person's mouth X minutes after eating foods that contain sugar. We want to use this function to answer the following. Okay, so what's X here? Taking like 100 times louder. Oh, okay, for part A, yeah, it's 18. In general, X is time, right? Minutes, yeah. So X is how much time has passed. Y is the pH, right? Okay, so again, any kind of application stuff, we always want to make sure we're really clear on like what's X and what's Y, right? X time, Y pH. Okay, so I would probably, start maybe by just graphing this thing, right? Here it is, that's in like a standard window. Do I really care about the whole thing, right? Because the function in the like abstract sense is defined, kind of everywhere, all kinds of places. Do I care about the whole thing in the case of this, particular like application problem? No, what do I really care about here? Like which parts of the graph do I really want to focus on, if not the whole thing? Really, I just care about what's going on in quadrant 1, right? Because think about what X is. It's minutes after something happened, right? Well, it doesn't tell me about what happened before the thing happened. So I really only care about quadrant 1. I might, zoom this a little bit so we can kind of see what's going on a little better. So if I really just care about quadrant 1, Christian, I think you said something about the y-intercept. There's the y-intercept. What's that y-intercept mean here? initial starting, right? Time is 0. The time here is minutes after something happened. That's like, I'm not going to get too into the biology part of things because I don't know it either. But the like resting pH, right? Sort of your like default equilibrium thing is 6.5. That's about neutral, if I remember pH right. So that's your initial value, your starting point. What does the function do after that? It dips. This point that's kind of highlighted, that's when it starts to turn back around. We don't need to know that, but it dips a little bit, then it starts to come back up. And then what's it doing after a long time? There's a horizontal asymptote, right? It's still increasing. It's still kind of gradually coming back up, but it's leveling off, right? The way I would describe the end behavior that way is basically like flat, level, horizontal, something like that. So it looks like we get a horizontal asymptote, right? Okay. Now let's see about answering the actual questions. What is the pH level 18 minutes after eating Zoe? Go. X is 18, right? So we're just plugging 18 in. So this isn't anything to do with this being a rational function. This is just how does a function work, right? If X is 18, what's Y? So we plug in 18. We take a minute to thank God or people or whoever for calculators, because I don't want to do that by hand. What do you get? 5 point. Rounded to the nearest 10th. Yeah. So 5, was it round 2? Sorry. 5.5. Okay. Yeah. Nearest 10th, like again, paying attention to that part. Like that means you don't need to do any of this by hand, right? And like, please don't, or like, I'll feel bad that, anytime somebody hands me a thing that there's like just a horrible amount of like multiplying things out by hand, I'm like, oh, I don't want you to do that because you're probably mad at me as you're doing it. Like just punch it all into a calculator. If something goes wrong, have a calculator, like leave it like this, that's fine, I don't care. Like I assume that at some point you know how to do this, right? So that's that. What is the equation of the horizontal asymptote? So that means that 18 minutes later, the pH is 5.5, right? What is the equation of the horizontal asymptote? Okay, how do we find that? Leading terms. What are the leading terms here? 6.5 x squared and x squared. Okay, so I separate those out. 6.5 x squared over x squared. What does that do? X squareds cancel, and you just get 6.5. What does that mean about the equation of the horizontal asymptote that goes with this function? Do it. Not 1, but 6.5. So when the thing is sort of balanced like this, like the degree on the top and bottom are the same, then what's going to happen is you're going to get an asymptote at sort of whatever's left after you reduce, right? So if it was x squared over x squared, then it would be like 1. That first problem we looked at, it was 3x squared over negative 3x squared, so it was negative 1, right? Here it's 6.5. Because the top and bottom are relatively the same size, except that this one is 6.5 times bigger, right? That means it's going to level off there. That kind of makes sense if you think, about the like very surface level, I kind of remember 9th grade biology version of this, right? The pH was at 6.5 to begin with. It dipped a little bit, but it's going to come back up to that sort of resting state, right? Again, like we're not getting into the biology and chemistry part of that. Don't read me wrong here. That's what's happening here. That horizontal asymptote at 6.5, this thing is gradually increasing back up to that. So how would we describe that or say like what that means about the pH level over time? I could say something like the pH, well, a horizontal asymptote is a like leveling off or approaching thing, right? So I might say something like the pH is, does leveling have 3 L's in it? I don't know. Leveling off, approaching, coming up to, returning. You know, whatever version of that sort of makes sense for you. At about 6.5. Now, at some point, like the scale isn't fine enough to tell the difference anymore, right? Because I think pH measurements, you only ever go to like maybe 1 decimal place or something anyway. But like, so the fact that it's, you know, in the abstract sense, like still slightly below or whatever, like that doesn't really matter for practical purposes at some point. After a long time, right? Or eventually, or something like that. Now, looking at the graph, after an hour, like I probably can't tell the difference anymore between the pH being, you know, whatever it actually is and being 6.5, right? So after an hour, like this is all done, but it's always talking about end behavior, which means what happens after a, you know, quote unquote long time, right? That could be an hour, it could be, you know, a billion years, but eventually what happens, right, is that it's leveling off somewhere. When X is big, what's going on? Okay, so again, I've got, you know, pretty version of solutions, all that stuff that'll be in Blackboard soon. Test review will also be in Blackboard at about the same time, probably in the next like 10 minutes. Homework's due tonight. Anything that you have questions about or whatever, I'm in my office for the next hour, or shoot me an email and I will see what I can do to get you sorted out, okay? All right, you guys have a good day. I'll see you tomorrow.